Everyday lives, we are very much aware that our eyes are responsible for gathering sensory information for us to be able to comprehend and perceive our surroundings. It mainly contributes to our understanding and mental capacity to acquire knowledge and details that can help us to form the abilities to interact with the environment. However, even with such an evident fact that our eyes possess this ability, that does not mean that there is only one, even more so a distinct or exactly similar pattern that each individual sees. There are occurrences where an individual set of visual system has a slight or even huge difference to others, setting them apart from one another. In such cases, it simply means that there might be an underlying effect or factor that is responsible as to why it happened.
The effect is named after the Czech anatomist Jan Evangelista Purkinje. Jan Evangelista Purkinje discovered the phenomena in 1819. He was a polymath who would regularly meditate at dawn while taking long walks through the flowering Bohemian meadows. Perkin observed that his favorite flowers were vivid crimson in the afternoon but dark at daybreak. He reasoned that the eye had two systems for seeing colors, one for bright, overall light intensity, and the other for twilight and dawn. The effect arises because in mesopic conditions, the outputs of cones in the retina, which are normally responsible for color perception in daylight, are pulled with outputs of rods, which are more sensitive under such conditions and have a peak sensitivity in blue-green wavelength of 507 nanometer.
In terms of physiology, this case occurs because in an individual's pair of eyes, there are sets of cones in the retina which are color sensitive. This set of cones are most sensitive to the yellow light, and along with these are the rods in which are more sensitive to light that makes it more valuable in the dusk, although it fails to distinguish colors. So for this matter, at low illuminance level, the Purkinje effect, also known as the Purkinje shift or dark adaptation, causes the human's eye's peak luminance sensitivity to shift toward the blue end of the color spectrum. The Purkinje effect is the propensity for the human's eye's peak sensitivity to shift toward the blue end of the color spectrum when exposed to low levels of light, and it is also known as the Purkinje shift or dark adaptation. This shift occurs as we transition from our vision in day and our vision at night, and back again. The Purkinje effect occurs at the transition between photopic or cone-based and scotopic or rod-based system. When insensitivity fades, the rod takes control, and before color fades completely, it moves the rod's peak sensitivity.
As previously mentioned, there is several interesting information in regards to Purkinje effect. The condition wherein when it is nighttime, the wavelengths of red light which are longer will now appear much darker than daytime, and so the shorter wavelengths of blue light will now appear much brighter. This simply means that there is a high tendency that red objects or even lights can be more difficult to notice at night compared to objects or light that are green or blue colored. One of the several examples of this is when the fire department started to get rid of the traditional red fire truck vehicles, especially since their vehicles are needed in emergency cases. Meaning to say, they are fast moving and must be seen by anyone on the road immediately. And having a red-colored vehicle won't be much of a help because of the Purkinje effect, since there are instances, such as the taillights of the vehicles, when they're at a stop are red-colored. This case is validated since a driver of a car will still be able to notice the red light.
Conclusion. Now that we have finally discussed the Purkinje effect, it is no wonder now that our eyes' vision isn't distinct and similar from time to time. They may change depending on the time or how it illuminates, creating different perception. This certain effect, among with the others, play a huge role in psychology since this sensation affects how our brain function, perceives and adapts to our environment. By discussing this topic, it has now created a more profound idea that perception of the same senses can still vary and change depending on the individual, since each person's brain interprets different stimuli, resulting to different perception. All in all, we must be aware of all these